Great. Hello, everyone here and online. So we met, I think, 2 weeks ago with the overview session. If you haven't, if you were not there, I think it would be a good idea to go and at least check the slides, because that's where we discussed what we are going to talk about and what is this about. So a quick introduction about myself. I'm the Director of Data Science at Scribd, and Scribd is a business about all-you-can-read books, where we give you access to as much books as you can read or listen to in a month. And from our team, Jonathan is sitting there. Jonathan, raise your hand if you're interested in what we do and how we do it. You everything. All right. So an important thing about after big events, we have a lot of connections, and we never talk, and I cannot tell the actual connections from the noise in the market. So let's talk before connecting on LinkedIn, because everyone I have on my LinkedIn, I know them personally, and I know exactly what they do, and so there is a reason for connecting on LinkedIn. So please talk to me before friending me. All right, what are we going to do here? First of all, the actual name of this series is Mathematics of Deep Learning, and that's what we discussed to have as a 3-part workshop. Why Mathematics of Deep Learning? Well, first of all, you should ask ASIC why they want to have this, but I can tell you roughly, because there are 2 ways that people usually start getting into deep learning. The hacky way, where you forget about what is going on. You have libraries and APIs, and you download them, and you go to getting started, and you run the first code. You give it numbers, it gives you numbers back, and so you're doing deep learning in no time, right? So that's one way. It works until it stops working, and when it does not work, you have no idea why it is not working. What is going on? And then you open up the books, and you see, so this is about transformers plus the attention model, and you find attention is all you need. So okay, so this is the reference. I have to read it, and then I'll be able to do it. And then you freak out because you see matrices and inversions and multiplications, and you stop there, right? So that we want to cover the basic stuff, very basic stuff, that will enable you to go and tackle the problems that way. The second way of doing deep learning is to start by reading books. And if you have done machine learning that way, you remember how disappointed you were when you finished reading a 500-page book on machine learning, and you could not load an image of a cat, let alone doing things with it, right? So that's the other extreme, which is not good. We are in 2019. We want good jobs, and to get good jobs, we need to be able to do things, and we need to be able to understand what we are doing. And that's the goal of this session. If it is very easy, I have reached my goal, because it is supposed to look so easy that after walking out, you will say, I could do it myself, right? So that's what we want to get here. We want to enable everyone here to go and continue. And this is very different from the traditional way of teaching, where you go, you have a syllabus, and then you go one by one, you make sure everything is covered, and then you memorize. And here I show you pointers, I'll show you directions, and then I'll send you off in different directions. And the rest of it, like 5% of the work is here, 95% is after we walk out, and everything that you do on your own. All right? So let's get to the 5%. What we will learn, I showed you a very quick overview last time. It's basically all those mathematical creatures that we deal with and we come across when we do deep learning, okay? And then we will go so we'll start by all the definitions and linear algebra and cost functions and nonlinearities and how we put them together. And at the same time, we will do all of this in Pytorch. So we will look at the definitions and the mathematics of it, and then we will see how we do these in Pytorch. If you know the math, good for you, do it in Pytorch. If you know Pytorch, good for you, listen to the math. If you know both, great, go and do the assignments. So we have many different ways to, and read the reading assignments that we have. We have some very interesting things happening today. The hands-on sessions are very small, one sentence problems that are designed to help us get familiar and get very comfortable with Pytorch from the start. Okay, so that's it. How you can get most out of it? Practice. Go, read, explore, search, and do it on your own. This is just an excuse, so you know that you have to do it yourself. How do we do deep learning in 2019? And that's a very important thing. If you look at how we have been doing things, everything has changed in the last couple of years. Deep learning has become commodity. It's everywhere. You have access to many different ways of doing it. Here, I'll show you a combination of a good software plus a good understanding of what is going on. And we will come back to this question at the end of the third session. And then I'll show you an even better way of doing deep learning in 2019. Okay, so let's start with this. What is Pytorch? If you're not familiar with Pytorch, let's go here. And so Pytorch is a library. There are many different frameworks that you can do deep learning in. Pytorch, TensorFlow, Keras, that is becoming TensorFlow, part of TensorFlow, MXNet, Scala deep learning, and a lot more. Why Pytorch is interesting is because the language is civilized. So when you look at it, you actually enjoy looking at it and reading it, and it's object oriented, and you have classes that you can work with. So for someone who is familiar with Python, everything looks very familiar. And it has great documentation. Everything that we see here, and by the way, I should also tell you, everything that we talk about today and we do and you see here or in the assignments, they are all available for free online. You could do it yourself. And this is true about everything related to deep learning and machine learning these days. Pytorch is available for free, and it has great documentation. So go read the documentation. That is the best way of learning Pytorch. What happened to my... All right, what you should aim for. You remember the thing that said medical imaging and building an app that works? And go read this paper, and by the end of this series of sessions, you should be able to understand what is in this. And so what is the problem? We have biomedical images, and we want to find the veins in them. All right, so we want to take this, extract that. I'm not promising that you will have the training data or everything that you will build, and you will build a business and sell it. But the main point here is you should be able to learn how this works. That is our aim. And by that, I mean you should be able to read the paper and understand what is going on without being scared of what is happening in the background. So this is the paper, this is the result, and here is the GitHub. You have everything you need to do it on your own. Everything else is detailed. All right, so you remember from our last session why deep learning works. So we demonstrated in a very rough way this theorem that you can approximate, so doing machine learning means learning a function that takes in an input and gives you an output. And this function is learned by looking at a lot of examples, by finding patterns in the examples. We have no idea what is going on there. We cannot write it in a closed form because it's very complicated, but we don't care. All we want is something that takes the input and gives me an output where in the observed cases, the output is very similar to what actually happens in real world, okay? So our goal is to approximate a function and learn a function in there. And we saw that with a multi-layer feed-forward system, we can build an approximation to any function, no matter how complicated they are. Okay, so if you didn't see that, go look at the last session and read the book, the deep learning book that I shared last time.
Clarify by last session, you mean the lunch and learn session?
The lunch and learn session.
And the
yes.
link is in the important documents.
The link is there.
Yes.
Okay, the link is there. You can look at it, and the demonstration is from a link that I have shared in those slides. All right. So, if you remember, we start by an artificial neuron, and this is what we want to talk about. We have inputs. We take the input, multiply it by a bunch of weights, and then we form a linear combination of all of this, and then we apply a nonlinearity to that, and then we get an output pretty much like this. And we saw that, and you can see that you can write your input as a vector, and you can write the weights as another vector, and multiplying weight by the input one by one, element by element, is equal to a dot product of the two vectors. And then we apply a nonlinearity there, and we get an output, and then we compare our output with the actual observation, and we say, how close am I to making the right observation, the right prediction? And we measure the difference somehow, and we call it the loss function. And then we iterate on on this whole thing using a way that we will see until we learn all of these weights and we find our solution. That's it. It's as simple as that. Okay. Now, we talked about a lot of words here, names that we are going to see what they are. But what you need to know at this point, right here, is that everything we are doing is a bunch of linear algebra for which we need to be able to work with vectors and matrices and tensors, and then non-linearities, and that's it. All right. So linear algebra and what are tensors and scalars? So a tensor is a fancy way of saying an n-dimensional matrix. Okay. What is a zero-dimensional tensor? It is a scalar, right? You have a scalar, it's always a scalar, nothing happens to it. If you rotate the universe, if you change the temperature, 2 is 2, nothing changes, right? Then we have a one-dimensional tensor, which is a vector. We call it a vector. And you have seen a vector, you know, how we plot it is always given in some coordinates. All right, so as soon as you have a vector, then you are sensitive to how you're picking your coordinate function. If I pick a vector which is like this and rotate my coordinate function, then the component, the elements in my vector change. And tensor has a much more sophisticated, mathematically sophisticated definition. We don't need to talk about it. Just forget about that. All you need to know is tensor is an n-dimensional matrix. All right. So one-dimensional tensor is a vector. Two-dimensional tensors are matrices, which look like this, and three-dimensional are cubes full of numbers, and then you can go to higher dimensions. All right, let's do it in Pytorch. And you will do all of this in the hands-on session, and we will walk through every step here, so you don't need to take any notes here. But let's look at how these things work. To start using Pytorch in the Colab notebook, we import it first. And for most of what we are doing today, for almost everything we are doing today, only import torch is enough. And then in torch, we have the tensor. And so we define a tensor we can define a tensor by giving it the elements of the tensor. That's one way. Sometimes it's useful, but when you start writing code and it gets complicated, you need more automated ways of defining your and instantiating your tensors. You can build a tensor by giving it a size. So this is a two-dimensional tensor, and then telling it to fill it up with random numbers. So it builds it builds a two-dimensional 5x3 tensor, and it fills it up with random numbers. Why random numbers are interesting? A huge part of starting to do something, I want to learn the weights and the bias in my network. Where should I start from? I usually start from a random point in the n-dimensional space. So I fill it up with random numbers, and then I go and learn the values during the training process that we will talk about in the third session. You can take a tensor and then change and define another tensor based on that, and change the the type of the tensor, keep the size the same, only change the type, and then fill it up with random numbers. So these are very useful functions when you start coding. Or you can take a tensor x that you have defined before and then fill it up with ones, number 1, with a given size. So you're basically changing everything there. In the hands-on session, we are going to experiment with all of this.